This is the beginning of section 2.4, and it is about linear functions, graphs, and slope. And the first part is about finding the y-intercept of a line from the equation y equals mx plus b, or f of x equals mx plus b. And then we'll be talking about 2 points on a line, and to find the slope, given a linear equation, derive the equivalent slope-intercept equation, and determine the slope and the y-intercept. And then last but not least, we solve applied problems involving slope. All these concepts actually have an application, and we'll see that. So first of all, we can define a linear function as follows. A linear function f is any function that can be described by f of x equals mx plus b. And to look at this, what this looks like in reality when we have an application, let's talk about the constant b called the y-intercept. So when you look at this equation here, f of x equals mx plus b, then this quantity here is called the y-intercept. So let's look at an example, and it says here graph y equals 3x and y equals 3x minus 6 using the same set of axes. Then compare the graphs. So let's do that, and we did this in the previous section, how to graph the equation of a line. And how to graph the line of an equation rather. And so let's do it here. So here we have the graph of the two equations, and what we notice is that the second one, y equals 3x minus 6, is the same as the other one, y equals 3x, but it is shifted down by 6 units. So the graph of y equals 3x minus 6 is a graph of y equals 3x shifted down 6 units. The next exercise asks us to graph y equals minus 2x and y equals minus 2x plus 3 using the same set of axes. Then compare the graphs. So we graph the two equations. Here's y equals minus 2x, and here's y equals minus 2x plus 3. And so we note that y equals minus 2x plus 3 is the graph of y equals minus 2x shifted 3 units up. So positive 3 means we shifted up 3 units. The graph of y equals minus 2x plus 3 is the graph of y equals minus 2x shifted up 3 units. And we are asked in the next exercise to graph f of x equals 1/3 x and g of x equals 1/3 x plus 2 using the same set of axes, and then compare the graphs. So here are the two lines corresponding to the equations y equals 1/3 x and y equals, f of x equals 1/3 x and g of x equals 1/3 x plus 2. So we can say that the graph of g of x is the graph of f of x shifted up 2 units. So here I wrote it down, the graph of g of x is the graph of f of x shifted up 2 units. You may have noticed that I graphed the equations like this without going through a table of values and what we've done before. And the assumption is that by now you already know how to graph the equation of a line, given the equation. If that's still not quite clear to you, please go back to the previous section and study how we graph these lines. So let's talk some more about the y-intercept. And the y-intercept of the graph of y equals mx plus b is the point 0, b, or simply b. So here's the xy coordinate system. Here's f of x equals mx plus b, and this is the point 0, comma b. It's really better to use the two coordinates to designate a point rather than just b. This is certainly better to describe a point with two coordinates. So let's apply that to exercises 4 and 5. Find the y-intercept. When we compare y equals 7x plus 8 with the equation y equals mx plus b, or f of x equals mx plus b, then we notice that the number without a variable is the y-intercept. So here the y-intercept would be 0, comma 8. And similarly, for exercise number 5, this is the mx term, and then the b would be minus 2/3. So the y-intercept in this case would be 0, comma minus 2/3. So the minus sign certainly matters. Okay, the next important topic is slope, and the slope is typically designated with letter m. So the slope m, and here it is defined as follows in the xy coordinate system. Here are our axes x and y, and here's the graph of an equation, of a linear equation, and we pick two arbitrary points. So here we're using subscript x sub 1 and y sub 1. So those are the coordinates of this point, and x sub 2, y sub 2 are the coordinates of the other point. So whenever subscripts are used, that means we're talking about a specific point. Now, the slope m of a line containing the points x sub 1, y sub 1, and x sub 2, y sub 2 is given by this expression. M is defined as rise over run. Now what is rise? Well, the rise is a change in y, and the run is a change in x. And what is the change in y? It is y sub 2 minus y sub 1. That's a change in y. And similarly, the change in x would be x sub 2 minus x sub 1. Later we're going to talk about why these equations, why this expression is the same as this one. The important thing is to stick with one designation, and this is the one that's most frequently used. These two expressions are equivalent, but I would recommend just stay with this method of computing the slope. Now, the slope is a number, and as a number, there are three possibilities. The slope can be less than 0, and that's a line, not necessarily through the origin, but in this case, it is through the origin, and is, in this example, minus 1, so it kind of drops from the left down to the right. That would be a negative slope. So just visualize what a negative slope looks like. It's in this direction. Could be this way or that way, but that's the direction of a negative slope. Then a graph with slope equal to 0 is simply a horizontal line. So in this example, f of x equals 3. So no matter what x is, the corresponding y value, the corresponding function value, is always equal to 3. So here we have 0 slope. And in the other example, we have y equals, here's the slope equal to 1. So so it's greater than 0, and so here's a line that rises from left to the right. That would be a positive slope. And in this example, f of x equals x, but that's what a positive slope looks like. So we can have negative slope, 0 slope, and positive slope. And just from looking at any graph, you should be able to determine whether it's a positive slope, a negative slope, or a zero slope line. And again, to redefine or define again what slope is, it's a rise over run, in other words, by how much the line rises divided by the run. And so that is the slope. In this example, the rise is 2, the run is 5, so it's 2/5, and again, that is the slope. In this particular example, it's just a number, but later on in the applications, we'll see that slope can have a lot of meanings, and it's a very useful number, as you will see once we get to the applications part. The next three examples tells you a little about the size, how much the slope really means, or what the difference is. For instance, here in the first example, the slope is m equals 3/10 or 0.3. So the line slopes in this direction. But when the slope gets bigger, like 10/3 or 3 1/3, it's a much steeper slope. So the greater the number, the steeper the slope. When we have negative slopes like minus 3/10 or minus 0.3, it leans in this direction, not much. But as the number gets smaller, in other words, more negative, minus 10/3 or minus 3 1/3, the line rises much more steeply. So this just to have a kind of a general understanding that the more positive the slope, the greater the slope is, so steeper the line, and the more negative the slope is, the steeper the line leaning in the other direction. Let's do exercise number 6. Graph the line through the given points and find its slope. So the given points are -1, -1, and 2, -4. So it's commonly assumed that this is the first point, that's the second point. It doesn't really matter. So we can just visualize that this would be x sub 1 and this would be y sub 1. And this would be x sub 2 and y sub 2. So the formula says for slope, y sub 2 minus y sub 1. So in other words, it is -4 minus -1. So we need to be real careful with all the minus signs here. Divided by x sub 2, which is 2, minus x sub 1. And x sub 1 is negative. Again, we have to be careful with the minus signs. We want to separate them by parentheses. So minus -1, that's a positive 1. And -4 plus 1 would be -3. In the denominator, we have minus -1, that's a positive 1, so 2 plus 1 is 3. So we have that. So -3 divided by 3 would be a -1. So now as we graph these, graph the line through the point, -1, -1 would be this point here. And 2 and -4, x equals 2 and y equals -4 would be this point here. 2 minus 4 is here, and this is our point -1, -1. So now all we have to do is draw a line through these 2 points. So notice we drew the line with the arrows at the end indicating that the line extends indefinitely in both directions. But what we don't have in this case, we don't have an equation. We don't know yet how to do that, but later on in the section, in this chapter, we learn how to calculate or determine the equation of this line given the points. Similarly, the other example is we are given 2 points, 0, 2 and 3, 1, and we're supposed to graph the line through these 2 points and find its slope. So let's find the slope, and the formula for the slope is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And let's say this is our first point, so this would be x sub 1 and y sub 1. And let's say this is our second point, we make that x sub 2 and y sub 2. So then we have the following numbers. Y sub 2 is 1 minus y sub 1, and y sub 1 is equal to 2, divided by x sub 2, which is 3, minus x sub 1, and x sub 1 is 0. So in the numerator, we have minus 1. In the denominator, we have 3. So minus 1 divided by 3, and typically we write this as minus 1/3. Okay, so now where are the points? Well, 0, 2 would be this point here. And 3, 1 would be this point here. And this is 0, 2. And now all we have to do is draw the line through the 2 points. So in summary then, here is the graph of the line between these 2 points, and the given slope is minus 1/3, and the line is leaning in the correct direction. It has a negative slope just from looking at it. In the next exercise, we are asked to find the slope of the line y equals minus 2/3 x plus 1, and use the points 9, minus 5 and 3, minus 1 to determine the slope. Okay, so the slope is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So let's say that this is our point x sub 1, y sub 1, x sub 1, y sub 1, and this is the point with coordinates x sub 2, y sub 2. So y sub 2, in this case, is equal to minus 1. And y sub 1 is negative 5. So minus negative 5 divided by x sub 2, which is 3, minus x sub 1, which is 9. This gives us then minus 1 plus 4, and it would be equal to 3. And 3 minus 9 is minus 6. And there would be so it would be 4 divided by minus 6, or 2 divided by minus 3, or typically we write it as minus 2/3. So that is the slope of this line, minus 2/3. Well, if you paid attention to the function here, here's our slope. You know, the coefficient of x, the number that multiplies the variable x, is the slope actually. So that's minus 2/3. But here's how we've computed the slope given the 2 points here. The next part is really important. From a linear equation in the form y equals mx plus b, we can read the slope and the y-intercept of the graph directly. So here's the slope-intercept form of the equation. The equation y equals mx plus b is called the slope-intercept equation because it tells us what the slope is and it tells us what the y-intercept is. So the slope is m and the y-intercept is 0, b. Again, notice it's a point, has 2 coordinates, so you always want to write as 0, b in that form. So find the slope and the y-intercept for this given function here. Well, when we compare this with f of x equals mx plus b, then we notice the coefficient of x is minus 8, which is the slope. So the slope m equals negative 8, and the y-intercept is 0,23. Again, the minus sign really matters because it tells us which direction the line leans, the graph. So it's very easy to look at the slope-intercept form and determine then what the slope is, the coefficient of x, and what the y-intercept is, 0, whatever this number is. Similarly, in the next equation here, we are supposed to find the slope and the intercept. Now notice that this equation is not in the form y equals mx plus b. So here we have to solve the equation for y first. So we do that by adding 10y to both sides. We subtract 5x from both sides to isolate the variable y, so minus 5x. And then to isolate y, we divide by minus 10. And minus 5 divided by minus 10 is positive 1/2. So 1/2 x minus 5 divided by 2. So the slope is equal to 1/2, and the y-intercept is equal to 0 minus 5/2. So I hope you were able to follow these simple steps for solving the equation for y. And then now we have this equation now is in the form y equals mx plus b, which makes it very easy to identify what the slope is. Again, the coefficient of x, 1/2 in this case, and then the other number would be 0, b for the y-intercept. Let's apply this to an example. Holiday sales. Retail sales during the holiday season have grown from $1,416.4 billion in 2002 to $655.8 billion in 2016. Find the rate of change in holiday sales with respect to time in years. So what they're asking us to find the slope of the line. So let's say this is our first point here, so our x sub 1, so to speak, and our y sub 1. And this would be our x sub 2, and this would be our y sub 2. So then the slope, the rate of change of sales with respect to years, would be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And there would be 655.8 billion minus 416.4 billion dollars divided by 2016. These are the years now, 2016, minus 2002. This year here, 2002. And that's equal to 239.4. And 2016 minus 2002 is 14. So then the answer is $17.1 billion per year. Now that's not how we typically write it, but I did it on purpose to show you that the slope in this case has meaning. So the slope m in other words, the change has been on average 17.1 billion per year. It has gone up by 17.1 billion per year for 14 years. So we typically say, 17 billion, 100 million. Per year. So how do we know what the units are, like $1 billion per year? Well, that's from the vertical axis. That's the change in y, the vertical direction, and that's in $1 billion. And then on the horizontal axis, we have years. So that will always tell you if these are done correctly, the axes are labeled correctly. That'll definitely tell you then what the unit of measure is for the slope. In this case, billions of dollars per year. And it's more common to write it the way it's written here at the end. The last exercise for the section is newspaper circulation. Daily newspaper circulation has decreased dramatically since 2005. The following graph shows the circulation of daily newspapers in millions for 2005 and for 2015. Find the rate of change in the circulation of daily newspapers per year. So we're given 1 point here, 2005, the year, and then the circulation was 53.3 million. And then in 2015 rather, we are told the circulation is 34.9 million. So let's write that down as our points. And so let's say that 2005 and 53.3. Let's say that's our x sub 1 and our y sub 1. And the other point, 2015 and 34.9 million, 34.9 is our x sub 2 and our y sub 2 correspondingly. So our slope, m, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 would then be 34.9 is our y sub 2, 34.9 minus y sub 1, which is 53.3 million papers, and our x sub 2 is 2015, and our x sub 1 is 2005. So when we do the subtraction here, we get minus 18.4 divided by 10, or minus 1.84 million papers per year. So in other words, the rate of change is minus 1.84 million papers per year. So what this last statement says, and of course also this one here just abbreviated, but what this last statement says that every year for the last 10 years, newspaper subscription or circulation rather has decreased by an average of 1.84 million papers per year. So every year that's how much circulation they've lost. And you can probably think about why that is so. Digital media would be certainly one reason for that. Anyway, that's the end of the section.